So welcome to my most favorite topic in data structures. Sadly, we don't get into it too in-depthly because you'll have it in algorithms or something else later on down the road in your career, but we at least get a little bit into it. So there's a couple of terms that we need to go over that's very consistent with all types of graphs. And I say consistent, but bad part is there's always two names for it. Like what we have right here, all the nodes, there also could be called vertices, or edges, which they can also be called links, so go figure. But a graph is made up of vertices and edges that you see the V and the E that you see there in the highlighted section there. Now notice the graph does not have to have every node or vertex connected by some edge in the graph. So you could have somewhere in the middle of nowhere, let's put it out here, and that's be fine. That's still considered a graph. So we talked about vertices already. Let's talk about the edges. In some graphs, the edges have a direction or an order. Now notice I said some graphs. So we would have our V be our starting point and our W be the ending point of the vertices. So it gives us some type of direction. Think about it going downtown and you have a certain direction, a one-way direction of a street. That will be represented by our edge of V and W. Next is path. Path is a sequence of edges to get from one spot to another. And then the length is how many edges did it take to get to that location. Now we have to watch is that our path may contain a loop or a cycle or something of that nature. We have to be very careful about that. And we have some checks that we'll do later on using disjointed sets to make sure we don't keep looping around and around and around. So think of this, I will also bring up Google Maps as a great example of what graphs are, because that's really what it is. Every point is an intersection, and your edges are going to be the roads to get to those intersections. So I'll bring up Google Maps quite often in all of our examples for graphs. But these are our starting terms.